Haplogroup R1b, also known as Haplogroup RM343, is the most frequently occurring Y chromosome haplogroup in Western Europe, as well as some parts of Russia and Central Africa. R1b also reaches high frequencies in the Americas and Australasia, due largely to immigration from Western Europe. There is an ongoing debate regarding the origins of R1b subclades found at significant levels among some indigenous peoples of the Americas, such as speakers of Algic languages in central Canada. It is also present at lower frequencies throughout Eastern Europe, Western Asia, as well as parts of North Africa and Central Asia, while Western Europe is dominated by the downstream subclades of R1b1b, especially R1b1b2. The Fulbe and Chadic-speaking peoples of Africa are dominated by the primary branch now known as R1b1a. The third primary branch, R1b1c, is rare and found mostly in Western Asia. Nomenclature: R1b, R1b1, and so on are phylogenetic or family tree-based names which explain the branching of the family tree of R1b. For example, R1b1a and R1b1b would be branches of R1b1, descending from a common ancestor. This means that these names can change with new discoveries. The alternative way of naming haplogroups is to refer to the SNP mutations used to define and identify them. For example, RM343, which is equivalent to R1b. Haplogroup R1b is, in other words, now identified by the presence of the single nucleotide polymorphism mutation M343, which was discovered in 2004. From 2002 to 2005, R1b was defined by the presence of the SNP named P25. Names based on SNPs thus remain constant. It is best to quote both. Before 2008, many different naming schemes existed. See conversion table for Y chromosome haplogroups. R1b was once known as HG1AU18. Origin and dispersal. R1b is a subclade within the macrohaplogroup K, which is one of the predominant groupings of all the rest of human male lines outside of Africa. K** is believed to have originated in Asia. The point of origin of R1b is thought to lie in Eurasia, most likely in Western Asia. T. Carafei al. estimated the age of R1, the parent of R1b, as 18,500 years before present. Early research focused upon Europe. In 2000, Ornellasemino and colleagues argued that R1b had been in Europe before the end of the Ice Age, and had spread north from an Iberian refuge after the last glacial maximum. Age estimates of R1b in Europe have steadily decreased in more recent studies, at least concerning the majority of R1b, with more recent studies suggesting an Neolithic age younger. Only Morelli al. have recently attempted to defend a Paleolithic origin for R1b1b2. Irrespective of microsatellite coalescence calculations, Chiki al. pointed out that the timing of molecular divergences does not coincide with population splits. The TMRCA of haplogroup R1b dates to its point of origin somewhere in Eurasia, and not its arrival in Western Europe. However, Michael R. Malio argues that the closest branch of R1b is from Iberia and its small subclades found in West Asia. The Near East and Africa are examples of back migration, and not of its origin. Barbara Iredi and colleagues were the first to point out that the distribution of R1b microsatellite variants in Europe forms a cline from east to west, which is more consistent with an entry into Europe from Western Asia with the spread of farming. A 2009 paper by Chiaroni et al. Added to this perspective by using R1b as an example of a waved haplogroup distribution, in this case from east to west. The proposal of a southeastern origin of R1b were supported by 3 detailed studies based on large data sets published in 2010. These detected that the earliest subclades of R1b are found in Western Asia and the most recent in Western Europe, while age estimates in these articles are all more recent than the last glacial maximum. All mention the Neolithic, when farming was introduced to Europe from the Middle East as a possible candidate period. Mayers et al. And Cruciani et al. Both remained undecided on the exact dating of the migration and migrations responsible for this distribution, not ruling out migrations as early as the Mesolithic or as late as Hallstatt, but more probably late Neolithic. They noted that direct evidence from ancient DNA may be needed to resolve these gene flows. Lee et al. Analyzed the ancient DNA of human remains from the late Neolithic Beaker culture site of Kromsdorf, Germany, identifying 2 males as belonging to the Y haplogroup R1b. Analysis of ancient Y DNA from the remains of populations derived from early Neolithic Central and North European linear pottery culture settlements have not yet found males belonging to haplogroup R1b. Structure. External phylogeny R1b is a part of the broader haplogroup KM9 and its linear descendants K2, K2b and P, which is also known as K2b2. pp295, pf5866, s8. P1q M242 R1R1A R1b. Internal structure. This is the basic outline of R1b according to the ISO-GG tree as it stood on January 30, 2016. Distribution. R1b*, R1b*, that is, males with M343, but no subsequent distinguishing S and P mutations, is extremely rare. The only population yet recorded with a definite significant proportion of R1b*, are the Kurds of southeastern Kazakhstan with 13%. However, more recently, a large study of Y chromosome variation in Iran revealed R1b*, as high as 4.3% among Iranian subpopulations, while studies in 2005-08 suggested that R1b*, may occur at high levels in Jordan, Egypt and Sudan. Subsequent research indicates that the samples concerned most likely belong to the subclade R1b1A2, which is now concentrated among African populations, following back migration from Asia. It remains a possibility that some or even most of these cases may be R1b*, R1A*, an otherwise undocumented branch of R1, and or back mutations of a marker from a positive to a negative ancestral state, constituting, in other words, undocumented subclades of R1b, thus demonstrating the importance of testing for SNPs critical in identifying subclades. A compilation of previous studies regarding the distribution of R1b can be found in Cruciani et al. It is summarized in the table following. R1b1, R1b1*, like R1b*, is rare. However, the skeletons of 2 males from both a Mesolithic pre-Yamna Samara culture burial dated to around 5650–5555 BC north of the Caspian Sea and an early Neolithic cardial culture burial dated to around 5178–5066 BCE candidate the Algic site, Aragon, in the Pyrenees, Spain, were found to contain R1b1*. Some examples described in older articles, for example 2 found in Turkey, are now thought to be mostly in the more recently discovered subclade R1b1a2. Most or all examples of R1b therefore fall into subclades R1b1c or R1b1a. Maulucioni al. in the large 2010 study found 3 cases amongst 1173 Italians, 1 out of 328 West Asians and 1 out of 156 East Asians. Vasari found 3 cases in the Ukraine, in a study of 322 people from the Dniester-Carpathian Mountains region, who were P25 positive, but M269 negative. Cases from older studies are mainly from Africa, the Middle East and Mediterranean, and are discussed below as probable cases of R1b1c. R1b1a. The SNP marker P297 was recognized in 2008 to combine M73 and M269 into one R1b1a cluster. The majority of Eurasian R1b is within this clade, representing a very large modern population. Although P297 itself has not yet been much tested for, the same population has been relatively well studied in terms of other markers. Therefore, the branching within this clade can be explained in relatively high detail below. The skeleton of a male from a Chalcolithic Yamna burial in the Middle Volga-Samara area, dated to around 3305–925 BC, was found to possibly contain R1b1a*, being P297 positive but L51 negative. R1b1a1a1, RM73 is reportedly the dominant haplogroup among the Kumandan of the Altai Republic in Russia, while early research into RM73 claimed that it was significantly represented among the Hazara of Afghanistan and the Bashkirs of the Ural Mountains. This has apparently been overturned. For example, supporting material from a 2010 study by Behar al. suggested that Sengupta al. had misidentified Hazara individuals, who instead belonged to R2aq. Likewise, most Bashkir males have been found to belong to R152 and some, mostly from southeastern Bashkortostan, belong to haplogroup QM25 rather than R1b. R1b1a1a2, RM269 is defined by the presence of SNP marker M269. R1b1a2** or M269 is found at highest frequency in the Central Balkans, notably Kosovo with 7.9%, Macedonia 5.1% and Serbia 4.4%. Kosovo is notable in having a high percentage of descendant L23** or L23 at 11.4%, unlike most other areas with significant percentages of M269** and L23** except for Poland with 2.4% and 9.5%, and the Bashkirs of southeast Bashkortostan with 2.4% and 32.2% respectively. Notably, this Bashkir population also has a high percentage of M269 sister branch M73 at 23.4%. 5 individuals out of 110 tested in the Ararat Valley, Armenia belonged to R1b1a2** and 36 to L23**, with none belonging to known subclades of L23. European R1b is dominated by RM269. It has been found at generally low frequencies throughout Central Eurasia, but with relatively high frequency among the Bashkirs of the Perm region and Baymakski district. This marker is present in China and India at frequencies of less than 1%. The table below lists in more detail the frequencies of M269 in regions in Asia, Europe, and Africa. Trofimova et al. Found a surprising high frequency of R1bl23 among the peoples of the Ural. 21 out of 58 of Burziansky district Bashkirs, 11 out of 52 of Udmurts, 4 out of 50 of Komi, 4 out of 59 of Mordvins, 2 out of 53 of Basurmian and 1 out of 43 of Chavashwa R1bl23. The type of R1b found in the recently analyzed Jamna remains of the Samara Oblast and Orenburg Oblast. The frequency is about 92% in Wales, 82% in Ireland, 70% in Scotland, 68% in Spain, 60% in France, 45% in Eastern England, 50% in Germany, 50% in the Netherlands, 42% in Iceland, and 43% in Denmark. It is as high as 95% in parts of Ireland. It is also found in some areas of North Africa, where its frequency peaks at 10% in some parts of Algeria. From 2003 to 2005, what is now R1b1A2 was designated R1b3. From 2005 to 2008 it was R1b1C. From 2008 to 2011 it was R1b1B2. As discussed above, in articles published around 2000 it was proposed that this clade had been in Europe before the last ice age, but by 2010 more recent periods such as the European Neolithic have become the focus of proposals. A range of newer estimates for R1b1b2, or at least its dominant parts in Europe, are from 4,000 to a maximum of about 10,000 years ago, and looking in more detail is seen as suggesting a migration from Western Asia via southeastern Europe. Western European R1b is dominated by RP310. In this period between 2000 and 2010 that it became clear that especially Western European R1b is dominated by specific subclades of RM269. Within Europe, RM269 is dominated by RM412, also known as RL21, which according to Myers et al. Is virtually absent in the Near East, the Caucasus and West Asia. Quote, this Western European population is further divided between RP312, S116 and RU106, S21, which appear to spread from the western and eastern Rhine River basin respectively. Myers et al. Note further that concerning its closest relatives in RL23*, that it is instructive that these are often more than 10% of the population in the Caucasus, Turkey, and some Southeast European and Circumuralic populations. In Western Europe it is present but in generally much lower levels apart from an instance of 27% in Switzerland's Upper Rhone Valley. Quote, in addition, the subclade distribution map, Figure 1H titled L11 in Myers et al. Shows that RP310 L11* occurs only in frequencies greater than 10% in central England, with surrounding areas of England and Wales having lower frequencies. This RP310 L11* is almost non-existent in the rest of Eurasia and North Africa, with the exception of coastal lands fringing the western and southern Baltic and in eastern Switzerland and surrounds. In 2009, DNA extracted from the femur bones of 6 skeletons in an early medieval burial place in Ergolding dated to around 670 AD yielded the following results. 4 were found to be haplogroup R1b, with the closest matches in modern populations of Germany, Ireland and the USA, while 2 were in haplogroup G2a. Population studies which test for M269 have become more common in recent years, while in earlier studies men in this haplogroup are only visible in the data by extrapolation of what is likely. The following gives a summary of most of the studies which specifically tested for M269, showing its distribution in Europe, North Africa, the Middle East and Central Asia as far as China and Nepal. R1b 1a 1a 2a 1a1. This subclade is defined by the presence of the SNPU 106, also known as S21 and M405. It appears to represent over 25% of R1b in Europe. In terms of percentage of total population, its epicenter is Friesland, where it makes up 44% of the population. In terms of total population numbers, its epicenter is Central Europe, where it comprises 60% of R1 combined. While this subclade of R1b is frequently discussed amongst genetic genealogists, the following table represents the peer-reviewed findings published so far in the 2007 articles of Myers et al. And Sims et al. R1b 1a 1a 2a 1a2, along with RU106, RP312 is one of the most common types of R1b 1a2 in Europe, also known as S116. It has been the subject of significant study concerning its subclades, and some of the ones recognized by the ISO-GG tree as of December 27, 2015 are summarized in the following table. Myers et al. Described it distributing from the west of the Rhine basin. Amongst these, scientific publications have given interpretation and comment on several. RP312A1A1A1A1 is defined by the presence of the marker M153. It has been found mostly in Basques and Gascons, among whom it represents a sizable fraction of the wide DNA pool, though is also found occasionally among Iberians in general. The first time it was located it was described as H102 and included 7 Basques and 1 Andalusian. RP312 This subclade is defined by the presence of the marker L176.2. It contains the following. RP312 1A1. This subclade is defined by the presence of the marker M167, also known as SRY2627. The first author to test for this marker was Hurls in 1999, who tested 1158 men in various populations. He found it relatively common among Basques and Catalans. Other occurrences were found among other French, British, Spaniards, Bayonnais, and Germans. In 2000, Rosser et al., in a study which tested 3,616 men in various populations, also tested for that same marker, naming the haplogroup HG22, and again it was found mainly among Basques, in lower frequencies among French, Bavarians, Spaniards, Southern Portuguese, and in single occurrences among Romanians, Slovenians, Dutch, Belgians and English. In 2001, Bosch described this marker as H103 in 5 Basques and 5 Catalans. Further regional studies have located it in significant amounts in Asturias, Cantabria and Galicia, as well as again among Basques. Cases in the Azores have been reported. In 2008, 2 research papers by Lopez Parra and Adams, respectively, confirmed a strong association with all or most of the Pyrenees and eastern Iberia. In a larger study of Portugal in 2006, with 657 men tested, Beleza et al. Confirmed similar low levels in all the major regions, from 1.5% to 3.5%. RP312 ALB2. This subclade is defined by the presence of the marker S68, also known as L165. It is found in England, Scandinavia, and Scotland. It has been suggested, therefore, that it arrived in the British Isles with Vikings. RP312b is defined by the presence of the marker U152, also called S28. Its discovery was announced in 2005 by Ethnoancestry and subsequently identified independently by Sims et al. Mayers et al. Report this clade is most frequent in Switzerland, Italy, France and western Poland, with additional instances exceeding 15% in some regions of England and Germany. Similarly, Cruciani et al. Reported frequency peaks in northern Italy and France. Out of a sample of 135 men in Tyrol, Austria, 9 tested positive for U152S28. Far removed from this apparent core area, Mayers et al. Also mention a subpopulation in North Bashkortostan where 71% of 70 men tested were in RU152. They propose this to be the result of an isolated founder effect. King et al. Reported 4 living relatives of King Richard III of England in the male line tested positive for U152. However, DNA analysis of Richard III's skeleton showed he had a haplotype GP287. The researchers concluded there must have been a non-paternal event in the intervening generations. RP312c is defined by the presence of the marker L21, also referred to as M269 and S145. Mayers et al. Report it is most common in England and Ireland. Known subclades include the following: RP312C1A1A1A1. This subclade within RL21 is defined by the presence of the marker M222. It is particularly associated with male lines which are Irish or Scottish, but especially Northern Irish. In this case, the relatively high frequency of this specific subclade among the population of certain counties in northwestern Ireland may be due to positive social selection, as it is suggested to have been the Y chromosome haplogroup of the UENE acute ill dynastic kindred of ancient Ireland. However, it is not restricted to the UENE acute ill as it is associated with the closely related Connacht dynasties, the Uí Brian and Uí Fiacrach. M222 is also found as a substantial proportion of the population of Scotland, which may indicate substantial settlement from Northern Ireland or at least links to it. Those areas settled by large numbers of Irish and Scottish emigrants such as North America have a substantial percentage of M222 RP312C1E1. This subclade within RL21 is defined by the presence of the marker L159 and is known as L159.2 because of a parallel mutation that exists inside Haplogroup I2A1. L159.2 appears to be associated with the kings of Leinster and Diarmait mac Murchada. It can be found in the coastal areas of the Irish Sea including the Isle of Man and the Hebrides, as well as Norway, western and southern Scotland, northern and southern England, northwest France, and northern Denmark. RP312C1B1B1A. This subclade within RL21 is defined by the presence of the marker L193. Many surnames with this marker are associated geographically with the western border region of Scotland. A few other surnames have a Highland association. RL193 is a relatively young subclade likely born within the last 2,000 years. RP312C1F2A. This subclade within RL21 is defined by the presence of the marker L226, also known as S168. Commonly referred to as Irish type 3. It is concentrated in central Western Ireland and associated with the Algic kindred. RP312C1 gram. This subclade within RL21 is defined by the presence of the marker DF21 aka S192. It makes up about 10% of all L21 men and is c. 3,000 years old. R1b1a2 R1b1a2 is defined by the presence of SNP marker V88, the discovery of which was announced in 2010 by Maulucioni al. Apart from individuals in Southern Europe and Western Asia, the majority of RV88 was found in Northern and Central Africa. As can be seen in the above data table, R1b1c is found in northern Cameroon in West Central Africa at a very high frequency, where it is considered to be caused by a pre-Islamic movement of people from Eurasia. R1b1a2a. R1b1a2a is a subclade of RV88 which is defined by the presence of SNP marker M18. It has been found only at low frequencies in samples from Sardinia and Lebanon. R1b1b. R1b1b is defined by the presence of SNP marker M335. This haplogroup was created by the 2008 reorganization of nomenclature and should not be confused with R1b1b2, which was previously called R1b1c. Its position in relation to the much more populous subclade R1b1a is uncertain. The M335 marker was first published in 2004, when one example was discovered in Turkey, which was classified at the time as R1b4. Prominent members. The DNA tests that assisted in the identification of Tsar Nicholas II of Russia found that he belonged to R1b. In popular culture, Brian Sykes, in his book Blood of the Isles, gives the populations associated with R1b the name of Oisin for a clan patriarch, much as he did for mitochondrial haplogroups in The Seven Daughters of Eve. Stephen Oppenheimer also deals with this haplogroup in his book Origins of the British, giving the R1b clan patriarch the Basque name Ruisco, in honor of what he thinks is the Iberian origin of R1b. Artem Lukashev has created an animation based on a Bashkir epic about the Ural, which outlined the history of the clusters of haplogroup R1, R1a and R1b. The R1by DNA discussion group is available for updates on the latest research in genetic genealogy.